Let's start with something really straightforward. We know that this syntax is enormously prevalent. So remember, this was the tautology, closing off a string and then using a statement that's always true. So the 1 equals 1 syntax is enormously prevalent. Now, there are some less prevalent alternatives that mean the same thing. And again, keep in mind the whole definition of a tautology is just to try and have a statement that's always true. So for example, this would always be true. It's a perfectly valid tautology. We're just matching two strings now instead. Or another example would be this one. 2 is always going to be greater than 1. That's always going to be true. But if the app is just looking for the or 1 equals 1 syntax, then this one will get through. Even a syntax like this is still accurate. It's syntactically correct because we have more characters after the F on the left-hand side of this equivalency. It's going to equate to true. So foo is actually greater than F. And this is the sort of thing that's often not looked for in signatures for defending against injection attacks. What you'll often find when trying these different attacks is that it's going to take a lot of probing. So you'll need to figure out what sort of patterns are rejected by the web app versus which ones are accepted. So this is very much a trial and error approach because so many web apps are implemented in different ways. That said, you'll also find that there are some known vulnerabilities within certain devices like WAFs and IDSs. So if you can identify what the device is that's actually protecting the app, you may well be able to find known risks within there that can be circumvented by some of these evasion techniques. So that's basic evasion. Let's go on and look at encoding.